Okay, so divisibility statements. So go straight into examples. So use mathematical induction to prove that 1 n to the power 3 minus 7n plus 9 is divisible by 3 for all integers n. So for all positive integers n. Okay, so the proof follows the same pattern. Step 1, step 2, step 3, step 4. So step 1, we always show that the statement is true for the smallest n. So for n is equal to 1. Okay, positive integers. So n must be 1. So we just substitute. So what we have is 1 to the power 3 minus 7 multiplied by 1 plus 9. So this is 1 minus 7 plus 9, which is negative 6 plus 9, which is equal to positive 3. And 3 is divisible by 3. Hence, the statement is true for n is equal to 1. So the first part is done. So you show for the smallest n, and it has worked. So let's go for the second part. Step 2, just make an assumption. So you assume that, the statement is true for n is equal to k. That's your assumption. Okay, don't worry about that. So assume that the statement is true for n is equal to k. So for n is equal to k, we have k to the power 3 minus 7k plus 9. Now to assume that the statement is true, you must assume that you can divide this by 3 and get a whole number. So suppose the whole number is m. Okay, so you're going to get m. So that if you are to cross multiply here, you have k to the power 3 minus 7k plus 9 is equal to 3m. So leave it in that way. So we are saying when you divide by 3, if it is divisible by 3, then I must get a whole number. Say m. Okay, where m is a whole number, where m is an integer. So now we go to step 3. So step 3, we prove now here. So we prove that the statement is true for n is equal to k plus 1. That is, where there is n, we put k plus 1 to the power 3 minus 7k plus 1 plus 9. So this must be divisible by 3. So to do that, Let us expand this. So using binomial, we have k to the power 3 plus 3k squared plus 3k plus 1. That's the easy binomial expansion. So we have this, then minus 7k minus 7 plus 9. Okay, so if we can put some things together here, going to have 3k squared here. 3k minus 7k, we'll get minus 4k, and 1 plus 9. What are we getting? We're getting 10. Okay, that's fine. So now, if we go back to step 2, so I'm saying by step 2, what do we have? In step 2, we have this statement, k to the power 3, k to the power 3 minus 7k plus 9 is equal to 3m. Okay, so if we are to solve for for k to the power 3, k to the power 3, we are going to get 3m plus 7k minus 9. So we're going to have something like that. Oh, okay, so here we have left out one thing. We have left out minus 7 from there. Okay, so when we substitute k to the power 3 for this, so where there is k to the power 3 there, we are going to have 3m plus 7k minus 9, then 3k squared minus 4k, that is going to be 3. 10 minus 7 is 3. Okay, so what we have here now is 3m plus 3k squared, 7k minus 4k, we get plus 3k, and plus 3 there. So if we factor out 3, what do we get? We get m plus k squared plus k plus 1. And this statement is divisible. Okay, we can say which is divisible by 3. So meaning that n plus k works. So we go now for step 4 and say, since the statement is true for n is equal to 1, for n is equal to k plus 1, then it's true for the assumption, which is n is equal to k, and hence true for all n positive integers. So that's how you follow induction. So I go through first. So you're saying if you have n to the power 3 minus 7n plus 9, you want to show that it is divisible by 3. The first thing that you need to do is to show for the smallest n. The smallest n is equal to 1. You substitute 1 where there is n, and you get 3. 3 is divisible by 3. So you are done there. Then the next one, step 2, just make an assumption that if we replace n is equal to k, then you are going to get something that is divisible by 3. Now, to show a statement that explains that this k to the power 3 minus 7k plus 9 is divisible by 3, we divide it by 3 and we must get an integer or a whole number, which is m. Suppose we have m. You can put anything here. You can put p, you can put y, anything. You can put x. So because we have m, if we cross multiply by 3, we're going to get this equation here. So we need this derivative so that when we get to step 3, where there's k to the power 3, we'll come back and solve it from this one so that we can go and substitute in the third equation statement. So we have substituted here where there was k3. We have brought in this part that came from step 2. Remember, step 2 is meant to help step 3. Without step 2, we cannot achieve the mission in step 3. That's the reason why induction does not fail unless you have a wrong statement. So it doesn't fail because it depends on an assumption. The second part, you just assume, and then use the assumption to prove something. So there's no way it can fail. Okay, so let's have another example. So another question, that is B. We want to show that this guy is divisible by 8.
Sir,
Yes.
I have a question, sir. Sir, on step 3, you make K cubed the subject. Now, is it always, what if I make K squared the subject?
So you make the easiest.
Okay.
So you make the easiest so that you avoid to start factorizing. Because if you look at where k squared is being multiplied by 3. So you know it's an easy thing. When I go the other side, I'll just multiply. Okay, so the proof, again, step 1. So we show that the statement is true for n is equal to 1. That is 9 to the power 1 minus 1. This is 9 minus 1, which is 8. And 8 is divisible by itself. Is divisible by 8. Okay. Hence, shown. So step 1 is very easy with step 2. Step 2, you just assume that the statement is true for n is equal to k. Okay. What do we mean? We mean 9 to the power k minus 1 is divisible by 8, meaning that it can be something like this. Divisible by 8. So we can go to step 3. That is, we prove that the statement is true for n is equal to k plus 1. So what do we do? Where there's n, we take k plus 1 minus 1. And if we expand, you know that when you have a sum in the powers, it means that we have a product of this nature, 9 to the power 1. So 9 to the power 1 is just 9. And so what we have is 9 to the power k minus 1, like that. So if we go back to step 2, so you can say by step 2, again, you're going to say 9 to the power k is the same as 8m plus 1. So you can get that and substitute. Where there is 9 to the power k, we put 8m plus 1 minus 1. This is going to be 9 by 8. We get, is it 72? So we get 72m plus 9 minus 1. This is just 72m plus 8. So we can factor out 8 again. So we're going to have 9m plus 1. And this is divisible by, 8. Okay, it's obvious. When you divide by 8, you're going to get 9m plus 1. And m is an integer. So you have an integer there. So step 4, the conclusion. So you say, since the statement is true for n is equal to 1, true for n is equal to k plus 1, then it's true for n is equal to k, and hence true for all n. So in this case, just want n natural numbers. So it means that our m is a natural number. So when you introduce m, you can even say where m is a natural number, to be sure that I don't have any remainder here. So that's the whole reason why we are bringing in such. We want us to be sure that there's no remainder there. Okay. Is there any question? Okay, so since there's no question, let's log out and log back.
So in the conclusion,
Yes.
is it always a must that you're supposed to end with the n is equal to k? Or what?
Yes.
What's so special about the n is equal to k?
So what's special about the n is equal to k is that it was an assumption in step 2.
8, 8.
So because it was assumption in step 2, we need to show its validity. You can't just assume something and go saying it works. We just assumed it. We didn't show, right? We showed for n is equal to 1. We showed for n is equal to k. What about for n is equal to k? So we showed for n is equal to 1 and n is equal to k plus 1.
Step 3 here where you written x plus
For your network. So I hope you get my point. So for step 2, we need to verify. We just assumed. That's why we are saying then it's true for n is equal to k. So the n is equal to k depends on n is equal to k plus 1 and n is equal to 1.
All right, thank you, sir.
All right. Wisdom, what's your question? No question.
Yeah, my question says on the first example.
Yes.
Yeah, flip to the first question, first example. Yeah, in the situation, sir, whereby you have the linear equation here, like k is equals to, k to the power 3 minus 7 to the power 2. How do you do? Do you expand them using binomial, all of them?
Yes, you expanded using binomial, all of them.
Right.
Yes. Yes.
How is here on the third step here 9, then 8m plus 1? Oh, 9m plus 1 is divisible by, how is it divisible by 8?
Not this one. This one we had to expand it. We expanded it to this part and it went this far. Then we factorized. Now we have 8, 9m plus 1. So when you divide by 8, you're going to get 9m plus 1. And m is an integer, so it's divisible. Is that okay?
You're saying n is an integer, then are you aren't you supposed to relate it to the question there? 9m n minus 1.
No, our interest is in 8. Is it divisible by 8? Okay. So what we have is, what we got is this 9, 8m plus 1 minus 1. So we want to make sure that this thing is divisible by by 8. So how does that happen? So you multiply 9 by 8, you get 72m. 9 by 1, you get 9. Then you have minus 1 there. This becomes 72m plus 8. Can you factor out 8? You factor out 8, you're going to remain with 9m plus 1. Now, m is a natural number. Natural numbers are whole numbers. So if we divide this by 8, we'll get 9m plus 1. And since m is a whole number, so we're going to have this whole thing as a whole number, meaning that that is divisible by 8. And where did this come from? It came from the statement 9n minus 1.
Right.
So that's the relationship.
And that was where the questions are again. What if you just divide this with factorizing? Here
What if you just
2m plus 8. What if you divide by 8? You divide by 8 instead of factorizing.
You only divide if it's an equation. Because if you divide by 8, you divide by 8, then what? So if there was a 0 here, we could do that. But now it's not an equation. So the only thing that you can do is to factor out.
I didn't get you.
So what you're saying is that you cannot divide if you don't have an equation. This is just an expression, so you cannot divide. So the division comes in if we had a 0. You could divide 8 so that it can go. But in this case, how do you divide the 8? It will still remain there. Because you're going to have 72 over 8 plus 8 over 8. So you have changed the question now. That's why I'm saying we only factorize so that you have 9m plus 1. If they say, give us back what you had, you just expand 72m plus 8. So I haven't changed anything. Okay, so let's log out and come back so that we can do some more examples.
Sir,
Yes?
so on step 1, n is always 1.
N is the smallest. So you'll see when you do inequalities, n can change from 1 to 3, from 1 to 2, depending on where the statement is starting from. So what we've been given here is a set of, here we've been given z plus, set of positive integers, so they start from 1. You've been given this natural number, so they start from 1. So that's why we go for the smallest. So n is just the smallest of the set given.
Oh, okay.
Yes.